Welcome to this brief video on strip method for slab design in Tekla Structural Designer. This video will concentrate on how to apply slab patches to create the traditional strip method design. Patches are very flexible and can be used outside of the strip method where needed based on actual stresses from the FE analysis. For more information, watch our other slab design videos. The strip method works best for orthogonal buildings. There are limitations on the slab spans and column lines with minimal offsets allowed. To demonstrate this design procedure in TSD, we'll use this simple one-story slab model. This is a flat slab with concrete column supports at uniform base spacings. I've already added dead and live loads to the slab. We can also see the floor plan view and update patterns to see the pattern live loading that's been applied on the slab. The slab design incorporates two features: the slab panel, which is the slab itself and we refer to as background reinforcement, and the slab patches. The patches are typically used in areas of high stress concentration, for example, adding more top reinforcing at the columns. In this case, the patches are going to be used to form the column strips for the design. The panel reinforcement will therefore be the middle strip. First, I need to define the center of the slab with construction lines. Use the construction parallel quick command, click on the exterior line, press F2 to input an exact value, and generate the grid line center lines. Now repeat for the other direction. Next, we can create the slab patches. The patch modeling commands are located in the design ribbon. Make sure to turn on slab patches in scene content before modeling so that you can see them as you go. These will form the column strips. You can see we have several different types of patches. These make it easier to model when using the stress areas instead of the strip method. But for this example, we'll be using the panel patch to lay out the column strips. The ACI code outlines how wide each strip needs to be based on the bay widths. In the Properties window, make a few changes to correctly lay out these strips. Uncheck the centroid option to place the patch anywhere on the slab. The corner points option allows you to manually draw on the slab where the patches will go, and you can click anywhere on the slab, use the tooltip to define the locations, or snap to existing construction or grid lines. I'm going to turn off this option and simply define the total dimension of the patch. I'll start with the patches or the column strips in the X direction. The dimension LX will be 70 feet, and the dimension LY will be the width of the column strip, which is 9 feet. Now I can click on the center point of the column strips along every column line to create the patch. Repeat the process for the Y direction. This time LX will be 7 feet and LY will be 54 feet. Again, click along the center line on every column grid to generate the column strips. Once the patches are drawn, select all patches in a given direction to set up the properties. For the column strips in the Y direction, set the Consider Strips property to Y, and set the reinforcement to bars Y. We have two options for working with these patches. One is for them to combine the reinforcement with the panel reinforcement. This assumes the panel reinforcement is placed over the entire floor plan and the patch reinforcement is additional steel. If this option is unchecked, the panel reinforcement will not be placed within the patches. Instead, the patch reinforcement will be the total steel required in this area. And for this example, I'm going to go ahead and uncheck this option to combine the panel reinforcement so that the slab patches have their own total reinforcement. There are a couple other options here as well that need to be set in order to properly lay out the bars. Now select the X direction column strips. In the Properties box, set the Consider Strips to X. Again, set the reinforcement to bars X, and uncheck the Combine with Panel Reinforcement. Note we can subdivide the column strips further if needed. Within the column strip, we can define a center design strip and two side strips. The program will then provide different reinforcing at the center and the sides. And I'll do this just for the X direction so we can compare with the Y that didn't have this option set up. I'll set the ends to be 1/4 of the patch length, so this will be 27 inches wide. The column strips and middle strips have now been defined, and we can proceed with the slab design. First, we need to analyze the building in order to get all of the forces in the slab. In the Analyze ribbon, click on Analyze All. Now, in the Design ribbon, the slab design is performed in two parts. First is the slab panel design. Click on Design Slabs. And again, this is going to be the middle strips. Second is the slab patch design. Click on Design Patches. Again, this is going to be the column strip design. The view will change to the Review view, showing a color-coded pass-fail of the slab and patches. Now we can investigate what reinforcing was placed in the different parts of the slab. Click on Slab Reinforcement. First, we'll look at the panel reinforcement, bottom reinforcing, and bars in the X direction. You can see that we have number 3 at 8 inches on center over the entire slab. Remember, this is only required in the X direction in the middle strip locations. We can also see this information for the Y direction. Change the slab property to the patch to see the reinforcing in the column strips. This is the top reinforcing in the X direction. Notice the column strips are broken into 3 parts and the reinforcing is decreased at the sides where possible. For the center column strips, the middle has number 4 bars at 8 inches and the sides have number 3 bars at 8 inches. And we can easily change the reinforcing to keep the same number of bars. In the Properties window, change the Apply property to User Bars. Now select the bar size and spacing that you want to apply. Click graphically in the corresponding slab patch to change the reinforcing. Now I can switch back to the slab status, right-click on this patch, and select Check Patch. This will recheck the patch design and give me an updated design status based on this change in reinforcing. You can see here the reinforcing is updated to number 4 is at 12 and everything is still passing. Back in the slab reinforcing, let's say I want to simplify this further and set the edge column strips to match the center ones. I can also click graphically on the patch to select a reinforcing to copy. Then click on the patch that I want to update. The same can be done in the Y direction. For the column strips in this direction, all bars are the same, so no further changes are needed. You can see here the column strips are not subdivided because I didn't define the zones like I did for the X direction. Let's switch now to a results view and take a look at the forces in the slab. Make sure to change the analysis type to the FE analysis. Also make sure to select a load case, combination, or envelope to review the results for. Look at the 2D results. Turn on the MDX top to see the stresses on the top of the slab. Same with the MDY top. You can see the traditional column strips do a good job of encompassing the high levels of stresses at the columns. Another way to review this information is to look at the required area of steel. Use this drop-down menu to select the direction and top or bottom of slab. Notice the contours now represent the area of steel per foot. Now for clarity, I'm going to turn off the slab patches and the area of steel required, and I'm going to turn on the results strips. These are the strips that the slab patches are using to design the column strips. We can view the forces in these design strips by turning on the corresponding force in the 2D strip results group of the ribbon. I'll turn on the moment, and we can also turn on the text to see the values. It can also be helpful to switch to a 3D view to see the diagrams. Right-click on a design strip and select Open Load Analysis View. This will now show you the loading diagrams for that particular design strip. Use the red slider bar to move along the strip and see the values in the Properties window table. Finally, the last thing we'll look at is printing a detailed reinforcement drawing of this slab. In the Draw ribbon, click on Slab Mat Detailing. Click OK to export the drawing to a DXF. If you have a DXF viewer or AutoCAD installed on your computer, the program will automatically open to show that drawing. This will show the slab and patch reinforcement as well as a legend with the bar information. There are several options for how to lay out this drawing within the Edit settings in the Draw ribbon in Tekla Structural Designer. That brings us to the end of this brief video on designing slabs with the traditional strip method in Tekla Structural Designer.